Welcome. Today I want to talk about how I develop software, how I refactor, test and document with Go. First, start with requirements. I like to use Gherkin. That's the link. And what shall we build today? Well, I want to build something that will maintain a comfortable temperature. So as a home resident, I want to have a comfortable temperature that is Goldilocks, not too hot, not too cold. Now, writing features, requirements like these are very important because, as you can see, the context is I'm a home resident and I need something to manage or control temperature. And I have two scenarios. When it's too hot, I need to be cooled down. When it's too cold, I need to be warmed up. So these requirements double up as user acceptance tests. So don't skip writing requirements. In fact, spend a lot of time writing requirements. This actually would be the most important part of the project. This helps you clarify your thinking and write the requirements, show it to your peers, have them critique on the requirements. Don't move forward until you are clear of what you want to build. Now, I'm a human like any other software engineer. I like to code, and this is an example of my first draft. It works. Let me show you. I'll copy and paste. Go over to my terminal, paste it there, boom, Control B. Yeah, so it's too cold if it's 24 degrees, it's too hot if it's 31 degrees, between 25 and 30 degrees. It's just right and not doing anything. All right, let's get back to the presentation. So this first draft is not very satisfying. It works, but it's really messy. So what do? I put it aside. I'm not happy with my code. I refactor. So my second draft is to refactor. Well, I need to have something that senses the temperature, and I need something that controls the temperature. So sensor and actuator. So here is my main program, and I'm using Go concurrency here. Very interesting. So temp, or short for temperature, is a channel of integers. Well, assume that temperatures are in 1 degree resolutions, and you can pass these temperature samples down a pipe or channel, and that pipe or channel is named temp. So sense would write into the temp channel, and actuate would read from the temp channel. And there's this funny select at the bottom of main. Why is it there? It's there because sense and actuate are Go routines. And notice I said sensor, but now in my main function I said sense, because it actually senses the temperature. Actuate, not actuator. We'll talk a lot more about this later, but for now, sense and actuate. So this is how the sense Go routine looks like. It's exactly like before. It now sleeps for 90 milliseconds. I didn't want to use the word the number 100 because I is less than equal to 100. I wanted to have a different number. Notice also I highlighted the main part of the code. I bracketed it on top and on bottom with a blank line. This brings out my main intent, because the Go function and the forever for loop, these are standard boilerplate Go routine things. So essentially what it does is, I just wanted to highlight here this funny construct, channel arrow into chan, means it only writes into the channel. Here's the actuate Go routine. It looks very much the same, but notice that I'm reading out of the channel now. This is always this construct, the less than and dash. It's always, this arrow is always pointing to the left. It's never pointed to the right hand side. So again, this is the standard Go routine boilerplate, and this is the main thing I want to highlight. And it's quite simple. If the temperature is less than a certain threshold, to cold; temperature greater than a certain threshold, to hot; otherwise just right. So refactor, test and document, that is the topic of my talk. Technically, we should actually all practice test-driven development, where we write the test first. But as you saw, I was a bit too keen and I refactored my code. Well, from that really messy first iteration to what it is now. But let's go ahead and write the test anyway. So that's why I say refactor test. In the ideal world, we sometimes forget to write tests, but I remember to write the test. So for the index and the data in the range of all the data available, this construct is pretty hard to read. If O equals actuate D dot I and all that, that's really hard to read. But I tolerate it, and in fact I encourage it because it makes the code shorter. And this is a construct which I use all the time. Basically says the output is get the output from actuate, and D dot I is the input. If the output is not equal to the expected output, flag the error. Again, this is not very readable code, but again I use it because this is standard boilerplate. So what is the data structure? It's an array of structures with input and output. And now this becomes very readable. The data is more important than the code in the test. So if I is 24, the input is 24, expect -1 as the output. If it is in the Goldilocks range, 25 to 30, the output will be 0, O and 0, bad practice, but what to do? I, O, 0, -1, 0, +1. And if it's 31, it's too hot, it should be +1. So -1 stands for cooling, 0 stands for don't do anything, 1 stands for warming. Now this is bad practice, but you can actually refactor this again to use Go enumerations, and you can actually use stringer to have, let's say, -1 represent the enum cooling, 0 to say no action or do nothing, and 1 to say heating. So you can look up on the internet on Go enumerations or Go enums and stringer. Now, obviously if I run the test now, it would fail. So I have to refactor my main now. After writing the test, I need to refactor my main. So I write the actuate function. It now takes an integer and not a channel of integers, and returns an integer. Notice I replaced the magic numbers with constants now. So low temperature, high temperature. My practice I keep the constants close to the function. Again, I'm accepting an integer and I return an integer. Go can do so much better, but I'm keeping it as it is because I want to show you how I think and how most programmers think. So the input should actually be a temperature, and the temperature should be a type in Go. So it could be alias to integer, or it could be alias to float 64. And the output should actually be an enumeration where it says cooling, no action, and heating. But let's go with this for simplicity to show you the more important things I want to highlight, which are the actuator now is used this way. All right. So actuate is the function we just wrote. This function, that's the function we just wrote. And it is called by the actuator. Actuator now accepts and reads from a channel of integers into that variable temp. Now, if you go and read Bob C. Martin's clean code, he actually encourages this form: display temp, actuate temp. I don't like that. I rather make the code a bit longer and make it a bit clearer by saying a new temporary variable t is actually extracted from the temp channel. O is the output of the actuate of the temperature, and display the results. And similarly, I wrote a new function named sense, which takes in a temperature, and this temperature is a channel of integers, and it is called by the object. It's a function, of course, but I term it as an object, sensor, and that's how sense is implemented. It's exactly the same code, but now refactored into its own short function. Quite short, quite easy to understand. The main function now looks like this. So this is my third draft. This is exactly the same, but now I've converted it back to nouns. Sensor, not sense. Actuator, and not actuate. Why did I do that? I did that because organizing or architecting software is very much like organizing a team. Imagine a soccer team. You have goalkeeper, you have striker, you have defender. These are nouns, these are names. So each team member has a name, and each team member is responsible for doing something. So what does it do? The sensor team member is responsible for sensing. That's why this is a name and this is a verb. Don't underestimate the power of these naming conventions, because it helps you clarify your thinking and helps you organize your code. So let's run this to make sure that it works. First, we need to go into the folder. Let's go in. Clear. Go test. Always test. It passes. Good. Go run main.go. And it works. Heating, not doing anything, and cancel. That's a go routine. So at this stage, we have refactored, we have tested, we have refactored again. Now we need to document. Software, very much like organizations, have things that change frequently and things that change less frequently, or things that are stable. So document stable things in the README. The README is something that is static. It's perfect for documenting things that do not change frequently. However, there are things or parts of your code that do frequently change. So document unstable things in a code walkthrough. First, let's look at the README. The README is the README in my repo. The title is developing software, and so on and so forth. It starts by defining requirements. Look at the slides. It requires the present tool. That's how you run the present tool. All this doesn't change. These things are stable. And the code walkthrough is in this particular file. So let's have a look at the code walkthrough. If I click on the code walkthrough, and I'll zoom in a little bit, this uses exactly the same present tool, except that it uses the article format and not the slide format. What are the benefits? Just reduce it slightly. It gives you an automated table of contents with clickable links. So if I want to click on the main function, it says my main function is here. Here's how the main function looks. That's the sensor. That's the actuator. Actuator goes down here. Now, you may be thinking that I actually typed in this code in the article format. No, it actually points to the code. So if I actually make an edit to the source code now, this will automatically be updated. This one I typed in though because I say I want to point to the command subfolder draft 3 main go. The purpose of this article format is not to be absolutely comprehensive. The purpose of this article format is to help new developers new to your code base, so that they can navigate your code base more easily. What is important for me to share with my colleague when navigating this code base? For me, I feel the requirements are very important. So I link the requirements in here. So again, if I change the requirements file, this article will automatically be updated. What is most important for a developer navigating the code base? The entry point, the main function. That's why I documented it here. And after looking at the main function, I go one level deeper, which is why I talk about the sensor and actuator here. Let's go back to actually I need to move out of full screen. Where it is, I go here, move out full screen, go back into this and go back into full screen. This, all right. So anyway, the presentation and code sources are available from my repository. It's GitHub Siu-Yin Developing Software. And thank you. I am Siu-Yin. I'm an engineering manager at Zendit. Zendit is hiring.